Good afternoon, everybody. My name is Vasif Mirza, and I'm the Director of Mobility Engineering, also known as ITS Engineering in the Division of Traffic Operations System and Support, TOSNS, in New Jersey Department of Transportation. First, I want to thank the organizers of this event to invite New Jersey DOT for today's presentation and also for selecting a project for offering the best TSMO strategy. When I learned about the selection of a project for the best TSMO strategy for those of us who are graduates of the FHWA Ops Academy, I want to let you know that I felt that I finally earned a membership in the TSMO club and got the permission to take a big sip out of the TSMO Kool-Aid by leading my team to follow what our instructor at the academy, the great Phil Tarnoff, grilled through our minds every day at the TSMO boot club at the academy when he said, we need you to drink the TSMO Kool-Aid and mainstream TSMO in your CMM, capability maturity matrix, in all dimensions. We are honored, humbled, and elated on getting this opportunity. And secondly, I want to thank the viewers who are logged in to view this presentation. Please note, we have a grand total of 10 minutes to describe a project that took 4+ years in making. And there's tremendous amount of information that we can share. So we are requesting forgiveness from everyone in advance if you find us skimming on details or feel we are rushing or that our presentation is weak on focusing on certain areas. This is only to respect and stay within the bounds of our quota of time. So if anyone is interested in learning more, please contact us. Next slide. I'm also honored and delighted to inform that for today's presentation, I share the limelight of the virtual stage of the computer camera time with few of my worthy colleagues and staff and the consultant that contributed for the Route 1 hard shoulder running. These are listed on the slide. From the New Jersey side, we have the project manager, Jose Romero, assistant project manager, Hiran Kumar Patel, and the both will be presenting today. From the consultant side, we have Tony Bartello, who was the project manager with Harold Calero as his deputy. They are listed over here, but they're not presenting. Besides that, obviously, we had a lot more people, but these are the main key players. Next slide, please. So why select this corridor? It is a typical principal signalized arterial, approximately 110 miles long, connecting many counties, running in the north and south direction along the state. During its entire length, there is not a section of the roadway that passes through what would be described as a rural or undeveloped section of the state. We are ranked 47th in size out of the 50 states, so not a very big state, but ranked number 1 in being the most densely populated state with a very high auto ownership and dependability on personal vehicles for travel. This characteristic can easily be witnessed every day in terms of congestion on the roadway network. We all have the capability of looking at each other's congestion through Google Maps, so feel free. During the entire section of the roadway, it is 3 lanes in each direction, with the exception of approximately 7-mile section through the township of South Brunswick in Middlesex County, where it is actually reduced to only 2 lanes. Needless to say, this creates the biggest bottleneck every day where the traffic comes to a halt as it squeezes through this section of the roadway. Some of the constraints and very high level, roadway through an extremely developed section of the state, roadway with only 2 lanes through this section with 3 lanes on either side. Township leadership residents extremely unhappy, hence very aggressive in asking for some solution. Presence of existing overhead utilities and underground utilities, you'll see some slides, and several environmentally sensitive sections along the roadway, and the cost and the time involved to provide a traditional solution was not feasible at all. So adding physical capacity beyond the existing footprint was not feasible, but squeezing more capacity from the same network by changing operational strategy was the best option. With this, now I will give the charge over to Jose to run and describe the next few slides. Jose, you're next.
Yep. Thank you, Wasif. Good afternoon, everyone. The problem in this corridor was there was a high congestion during peak periods in this area. This was, as Wasif mentioned before, attributed to there being a bottleneck as the roadway transitions from 3 lanes to 2 lanes, both downstream and upstream of the corridor. There was a need to expand the capacity in this corridor, so initial looks at widening the roadway determined that it would be too costly due to requiring right-of-way acquisition, utility relocations, both overhead and underground, and the construction itself. Other issues, such as there being many environmentally sensitive areas, also deter from this strategy. So other solutions had to be considered to solve the problem. Since the roadway has the 2 travel lanes as well as a shoulder, the hard shoulder running TSMO strategy was implemented to maximize the use of the existing rotary capacity during peak periods to alleviate congestion. Next slide, please. There was a high risk of implementation of this strategy on the arterial that has so many entry and exit points, so an initial pilot project was first deployed. This pilot project allowed the use of shoulder within the corridor during both AM and PM peak periods for passenger vehicles only. Static signs were deployed advising motorists of the allowable use times and restrictions throughout this corridor. Due to the high number of driveways in this arterial, signs were also deployed at all exiting driveways to alert the motorists of the shoulder use to avoid any issue while exiting onto the shoulder. Temporary utility pole mounted cameras were installed to monitor the traffic conditions and the use of the shoulder during operation. All signals and radar detectors throughout the corridor were optimized for this strategy. Next slide, please. A few months after implementation, an assessment of the pilot project showed improvement in the conditions. This report here represents before and after congestion analysis during the same time period using data from the RADARS tool. As you can see, vehicle speeds increased during the peak periods, and the key bottleneck located at Ridge Road, there was a reduction in the congestion. Travel time decreased during the peak periods as well as the delay costs. Next slide. Here you can see a side-by-side comparison of before and after the pilot deployment. Both the AM and PM peak periods showed improvement in both travel directions after the deployment. Therefore, given the success and benefits found from this deployment, it was determined that we will proceed with a permanent solution. My colleague Hiren Kumar Patel will now go over the permanent solution project details. Hiren?
Thank you, Jose. Good afternoon, everyone. So after having a successful um, pilot program, we decided to implement HeartSorter as a permanent solution utilizing ITS devices. HSR system should operate autonomously and is compatible with existing NGDOT traffic management system. We decided to provide a signage at the advance of the segment, throughout the HR segment, and also at the end of the segment at constant intervals. Most of our mobility engineering projects are limited scope, where we try to avoid impacts with right-of-way, utility, and environment. And so as a permanent solution, we decided to include lane use control signal, CCD cameras, dynamic message signs using our existing fiber communications. Next slide, please. So unlike a static sign, lane use control signal provide a clear indication whether to motorists when shoulder is open or closed. As I mentioned, they operate autonomously 24 hours, indicating a green arrow when the shoulder is open and red X when shoulder is closed. LUCS sign were spaced at interval of 1200 to 1500 feet between signalized intersections. Instead of a blank out sign, we use a small Tektronix DMS sign. They were easy to integrate into our Tektronix Vanguard system and also provide a flexibility in messaging if necessary. Next slide, please. We installed two different kind of cameras. One on right, you can see on 75 pole. They were installed at each signalized intersections, which were installed to provide a visual coverage. And each LUX sign install a fixed pedestal camera on LUX sides to provide a visibility of shoulder lane at all time and ensure shoulder is safe to travel for motorists. Next slide, please. TMS sign were installed at the advance and at the end of the HR segment to provide the advance notice for hard solder and also for other travel incidents. We had to install ground mounted DMS sign where we had overhead issues. Next slide, please. Challenges. So every project had their own challenges regarding the utilities. We either have an overhead issue or we have an underground issue. In our project, we had to deal with both. As you can see, the deployment was on arterial roadway. There are utility poles on both sides of the roadway, plus these are signalized intersections, and Jose mentioned there are drivers as well. We also had very limited right of way through this on this corridor. Next slide, please. As you can see in the sketch, there are a number of utilities for the overhead, and we have to ensure that we comply with OSA and our OSA guidelines and our state statutes requirements. And similarly for the underground, we meet the clearance requirements as per utility guideline. There were some sites, they were in environmental sensitive areas, so we had to obtain all necessary permit for that. And during construction, we came along some sites where we had shallow rock. So either we had to relocate the site or use the special equipment for foundation work. Next slide, please. So the total summary, so the summary of the project, total construction cost was about $5.2 million. Construction length was about 24 months. And in total, we installed 14 LUCS signs, 24 cameras, and 4 DMSs. Next slide, please. So this is the final some additional pictures of final completion of hard solder running with the log sign and some additional static sign that we install as a part of our project. With that, I'm going to hand it over to Wasif, who's going to go over the final conclusion of our presentation. Thank you.
Thank you, Aaron. This slide is generated using the Redis heat maps, and in today's use of Google Maps and the GPSs, I don't need to describe what the different shades of green or bleeding of the other colors mean. Green is good, red is bad. The slides describe using the colors the improvement in travel time by comparing the 2016 with 2021. This is the 2021 data when the traffic was back again up to the pre-COVID levels. 2016 being the year prior to the pilot project and 2021 being the latest numbers. As it is evident, there is significant reduction of travel time in both direction of the travel for peak periods. We stay in close contact with the local PD, and there has been no increase in accidents related to the use of the traffic on shoulders. With this, we come to the conclusion of presentation, and as Adam, this is back to you for any Q&A later on. Thank you.